What's up, guys? We're starting our unit on statistics, and to start off, we're going to use the 5-number summary to talk about how our data is arranged in terms of center and spread. The 5-number summary is a basic calculation on your calculator, and to do it, here's some example numbers. So let's suppose that somebody had 12 tests in one of their classes, and these were their test scores. I arranged them from low to high to help me talk about them. Okay, sometimes they won't be in order and you have to do this yourself. We have 12 test scores here, okay, ranging from 70 up to 89. The 5-number summary is going to be 5 numbers. You've got the minimum, which in this case would be 70, the maximum, which in this case is 89, okay, so that's 2 out of the 5. Next, you have the median, which you probably know already. The median is the middle number if they are ranged from low to high. Well, since we have 12 numbers here, there is no middle number, but counting from both ends down towards the middle 2 numbers are both 82. And when that happens, then the median is the average of those 2 numbers. What's halfway in between 82 and 82? Well, since they're the same number in this case, the median is 82. So we already know the minimum is 70, the maximum is 89. The median is 82, okay? So it's halfway in between those. Now, the next 2 numbers are what's called, we call them Q1 and Q3, and that's for quartile. Quartile 1 and quartile 3. You also hear them referred to as the upper and lower quartiles. This would be the lower quartile and the upper quartile. So if the median divides the data into halves, you got the lower half and the upper half, the quartile divides those halves into halves, okay? So if this top row is the lower half of the data, then if I cut that in half, halfway in between here would be quartile 1. So quartile 1 is like the median of the lower half. And again, since there's an even number of data points in this half, I have to get the average of these 2. So if I add those together and divide by 2, I would get 74.5. And Q3 is halfway in between the 2 middle values and the upper half, okay? It's like the median of the upper half. And halfway between 85 and 85 is 85. Okay, so this is the 5-number summary. Now I want to show you how to find this on your calculator so we don't always have to write these out. To do that, I have one of the multi-view calculators here, okay? And what we want to do is go to where it says data, and in L1 you just want to type out all of your data, and I've already done it, okay? Once you've got that all typed out, you hit second data for stat. And since we just have one variable, we're going to go to 1 var stats. That's for one variable. There's a couple options here. Okay, since I entered everything into one list, the data is in L1. The frequency is 1. That means there's 1 of everything that I entered. Okay. Now just before I hit calc, I want to show you the other option. The other option would be to use what's called a frequency table, which you've probably seen before, where instead of listing out all the data values here, we list out only the unique data values, and then over here we say how many of them there are. So if you had a lot of repetition in your data set, like for example, I've got 2 82s and I've got 2 85s. Well, if I had a lot of repetition, like maybe I had 5 70s and I had like 6 of the 72s, then you would just say 70, I had 5 of them. 72, I had 6 of them. You would say how many of each one you had. If you did that, then when you went to stat in 1 var stats, you would say data L1, frequency L2, letting the calculator know that L2 has, that second column has the frequency of your data. But since I just entered it all in one list, L1 is my data and the frequency is just 1. There's 1 of everything that's in there. We go down and hit calc. This is going to tell us a bunch of stuff, and we're going to use a lot of this as we go throughout this unit. But for right now, the 5-number summary is going to be at the bottom. Okay, starting with min, Q1, median, Q3, and max. And if you notice, those are the same numbers we wrote. It's in a little bit different order. This is usually the order I'll put it in. Okay, 70, 74.5, 82, 85, and 89. These match up to what I have up here, just in a different order. Okay, so one of the things we're going to do with a 5-number summary, and you need to be familiar with this, is called a box plot. Sometimes called a box and whisker plot, depending on whether or not you add that part of it. The box plot is a graphical representation of the 5-number summary, okay? And you've probably seen this before. You may have done this before, but let's go through it here. So we're just going to basically put all 5 of these on a line. So you've got this line here that goes from 0 to 100 because that's theoretically the range that the grades could fall into, okay? The mean, or sorry, the median goes in the middle. It's 82. So 50, 60, 70, 80, 82 is probably about right here. I'm just going to put a little line right here, okay? It's probably about 82. The min and max are at 70. I'm going to put a dot for those. So the min is at 70. There's a little dot right here. And we'll put a little dot at the max of 89. So here's 89 right about here. Okay. And then for the first quartile and third quartile, we'll put another line also. So 85, there's a line. And Q1, 74.5. So right about here, there's a line. Okay. These make up a box. And then we draw a little whisker out to these min and max. Remember, this is the min, the max, the median's in the middle. This is Q3, and this is Q1. Okay, now this part doesn't normally go on the graph, but just this box and its whiskers. Okay, this is what's called a box and whisker plot. It shows how the data is arranged. Now remember, the median is the middle of the data. And these are the middles of the middle. So what this means is each little section is 1/4 of your data. 1/4 of the lower quarter of our data, in other words, the lower 3 data points, were between 70 and 73. The next 25%, the next quarter of our data, is between 76 and 82, which is right here. And so on. These are each 1/4 of the data. That also means the box in the middle is half of our data. It's the middle half, the middle 50%. And we actually call that the interquartile range, okay, or sometimes called the IQR for interquartile range. The interquartile range is the distance between Q1 and Q3. Okay, so since Q1 is 74.5 and Q3 is 85, the IQR in this case would be the distance between those, which is 10.5. Okay. In other words, that's 85 minus 74.5. It's the distance between these, okay? And one more topic we need to talk about is the concept of an outlier, okay? Let's say these were your test scores and you decided that you weren't going to study for the last test and you bomb it and unfortunately you make an 18 on that test, okay? This is what's called an outlier. We call it an outlier because it's way outside the data set. Now, there's actually no official designation for what makes it an outlier. There's no widely accepted criteria that it's got to be so far from the rest of the data. It's just universally understood to be something which is very far from the rest of the data. And there's different criteria you can use. The one that we're going to use is, we're going to say that something is an outlier if it is 1.5 times the interquartile range from one of the quartiles. Okay, so what does that mean? This box right here is the middle 50%. So this is the interquartile range here. Okay, if I were to take that box and do it again on the end and then do it one more half of a time. So if I take the length of that box and if I go that distance over here, so maybe it's like this. Okay, that's one more interquartile range. And then I go another half, so it's like probably out here somewhere. Anything beyond this point would be considered an outlier. And the same thing on this side. So take that length, and I'm just kind of estimating here. Like it's probably like right about here, right? And if I were to go that half again, it's like out to here. Anything beyond this point would also be an outlier. Mathematically speaking, we can do this. 1.5 times the IQR. 1.5 times the IQR, that's 10.5. Let's clear this out. So if I do 10.5 times 1.5, that's 15.75. So that means if I go 15.75 units above 85, which is like 100.75, and if I go 15.75 below Q1, which is about 59, okay? Anything outside of that, anything below that number, above this number, would be an outlier. So in this case, clearly 18 would be an outlier. It'd be way outside of that range, okay? It would only need to be less than about 59, and this is way below 59, so this would be considered an outlier. So when you're testing your data, if they say, are there any outliers, you find the interquartile range, multiply that by 1.5, then you add that number to the first, or add it to the third quartile and subtract it from the first quartile. Anything outside of those numbers, bigger than what you got here and smaller than what you got here, anything like that is going to be an outlier. One more fact about outliers that we need to talk about is how it affects mean versus median. So I put the data set back up here the way we had it before. And we want to talk about the mean and the median. Okay, so this is the original data set without the outlier, okay? And let's go back. Let's go to my data. Delete that out. Okay, so I'm going to go to one variable stats, and let's look at what is the mean. The mean is 80.3 currently. And the median, we said, let's go look at it again, is 82. Remember that the median is halfway in between these two numbers, which is what makes it 82. All right, so what if I add in that outlier? So I'm going to put in an outlier of 18. I'm going to write it over here because it's actually kind of on the low end, right? This is definitely an outlier that's going to have a huge effect on the grade. Even with this many test grades, that's still going to bring it down. Let's see how much it brings it down by. So I'm going to go to data, go to the bottom of the list, and I'm going to add in an 18 at the bottom. Okay. Now when I calculate my stats, the mean has dropped to 75.5. So they lost almost 5 points, okay, about 4.8 points. The median, on the other hand, I really don't even need the calculator to do this. Remember, it was halfway in between the 82s, right? Since I've got a new data point on the low side, the middle is now no longer in between these two. It's now going to shift, and it's actually going to be this. And the reason I know this is count from the right. 1, 2, 3, 4, 5, 6, and then you've got the median. 1, 2, 3, 4, 5, 6, and then you've got the median. Say I were to put another outlier on here. Again, this would just shift one place to the left at worst. It's going to really go here, and it's going to be the average of these two. So the worst thing you can do with an outlier is shift the median one place left or one place to the right, which ultimately is not going to have a very, very big effect on the data. On the mean, however, it has a huge effect. In this case, it didn't even change the median at all. It stayed the same. Even right now, if it were to shift, it would just go to whatever's halfway in between. If I were to add another 12 right here, for example, it would just go another, whatever, this direction, halfway in between 79 and 82. It just shifts one place to the left. That's all it can do, is shift left or shift right one place by however much these numbers vary. That's not going to have a very big impact compared to the mean, which is going to make a big difference. What that means is the mean is more affected by outliers than the median. Okay? More affected by outliers. This is very important. Oftentimes you're going to need to decide which is the better measure of center. And it kind of depends on the context of the problem. And it also depends on whether or not there's outliers. Anytime you have outliers, the mean is going to be skewed by that outlier. It's going to have a huge effect on it. Maybe you want that effect. In case, if I'm doing grades, if you get an 18, I want that to bring your grade down because it shows that you didn't understand it. It brings your grade down. I'm sure students would love it if they can make an 18 and it only shifts the median down, and that's what we measure. But we don't measure median when we measure grades. We measure mean. But if you're talking about real estate, for example, and one person in your neighborhood lets their house get run down and their property value drops really low, you don't want that to bring down the value of everybody else's house, which is why home prices tend to go by median rather than mean. It eliminates those outliers on both ends. If someone comes in the back of your neighborhood and builds a multi-million-dollar mansion, it will increase your property value probably, but it's not going to have a huge effect because they tend to look at median and not mean.